We are like the planets in the solar system. My heart has storms like that of Jupiter. And just like Saturn, you are breathtaking. Our love is as red as Mars, and together we are the stars. Solar system. Our solar system is a wondrous place. Countless worlds lie spread across billions of kilometers of space, each dragged around the galaxy by our sun like an elaborate clockwork.
Our solar system, formed about 4.5 billion years ago, that is gravitationally bound system of the Sun and the objects that orbit it.
Our solar system consists of our star, the Sun, and everything bound by its gravity. The planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Dwarf planets such as Pluto, dozens of moons, and millions of asteroids, comets, and meteoroids.
Did you know that the solar system has three hypotheses: nebular, encounter, and protoplanet? Yes, you heard it right, protoplanet. Let's go to our main topic. Next!
There are several theories that is made up on how the universe began. Some of it has their own beliefs, and that is also worth pointing out. But right now, we're talking about the protoplanet theory.
Within recent years, scientists have taken a closer look at the possible nebular origin of the Earth and devised a new theory in the light of newer findings. This idea has replaced the original nebular hypothesis of God and Laplace as well as the later planetesimal hypothesis. The revised theory, known as the protoplanet hypothesis, was first proposed in 1944 by Carl Friedrich von Weizsäcker and modified by
Gerard P. Kuiper.
But who are they?
Friedrich von Weizsäcker was a German physicist and philosopher. He was the longest-living member of the team which performed nuclear research in Germany during the Second World War under Werner Heisenberg's leadership. Weizsäcker made important theoretical discoveries regarding energy production in stars from nuclear fusions and processes. He also did influential theoretical work on the planetary formation in the early solar system.
Gerard Peter Kuiper was a Dutch astronomer, planetary scientist, selenographer, author, and professor. He is the eponymous namesake of the Kuiper belt. Kuiper discovered several binary stars which received Kuiper numbers to identify them, such as KUI-79.
The protoplanet theory is a modified version of a nebular hypothesis. Just like a nebular theory, protoplanetary theorists Carl von Weizsäcker and Gerard Kuiper believe that the solar system started from a nebula.
Protoplanet is a large body of a matter in orbit around the Sun or a star thought to be developing into a planet. Protoplanet is a hypothetical eddy in a cloud of gas or dust that became a planet condensation during a formation of a solar system. The thinner material of the planet is believed to be driven off the increasing pressure of the central body.
It has been found that rapidly nebulas will develop large whirlpools or vortexes at various specs on the disk of nebular material. Each of these great whirlpools might then have collections surrounding materials by gravitational attraction, this forming a protoplanet.
It is believed that 9 protoplanets, one for each of the present-day planets, were formed, and these were originally much larger than the finished planet. Smaller whirlpools developed inside some of the larger vortexes, and this gave rise to the spinning disks that became the satellites or moons of the planet.
Many astronomers support this theory because observation through large telescopes have revealed a numerous true nebulas between the stars. Equally significant is the fact that some of these massive swirls of gas and dust are actually condensing to a new form of stars. The protoplanet hypothesis is generally acceptable to most scientists because it explains many of the most known facts about our solar system. It is nonetheless far from complete, and the origin of the solar system and Earth is still largely in the realm of speculation.
About 4.6 billion years ago, as the theory goes, the location of today's solar system was nothing more than a loose collection of gas and dust, what we call a nebula. Orion's Nebula is one of the most famous examples you can see in the night sky.
According to one idea, the location of today's solar system was nothing more than a loose of gas and dust called a nebula for 4.6 billion years ago.
Then something happened that triggered a pressure change in the center of the cloud, scientists says. Perhaps it was a supernova exploding nearby, or a passing star changing the gravity. Whatever the change, however, the cloud collapsed and created a disk of material, according to NASA.
And according to the scientists, something happened that caused a pressure change in the cloud's core.
The center of this disk saw a great increase in pressure that eventually was so powerful that hydrogen atoms loosely floating in the cloud began to come into contact. Eventually, they fused and produced helium, kick-starting the formation of the sun.
The center of this disk saw something significance in pressure, which became so strong that the hydrogen atoms freely collide in this cloud.
The sun was a hungry youngster. It ate up 99% of what was swirling around, NASA says. But this still left 1% of the disk available for other things. And this is where planet formation began.
The sun was a hungry youngster back then. It ate up for like 99% of the pressure swirling area. But NASA says there's plenty of things that is left behind. And this is where the planet information began.
The solar system was a really messy place at this time, with gas and dust and debris floating around. But planet formation appears to have happened relatively rapidly. Small bits of dust and gas began to clump together. The young sun pushed much of the gas out to the outer solar system, and its heat evaporated any ice that was nearby. Over time, this left rockier planets closer to the sun and gas giants that were further away. But about 4 billion or so years ago, an event called the Late Heavy Bombardment resulted in small bodies pelting the bigger members of the solar system. We almost lost the Earth when a Mars-sized object crashed into it, as the theory goes.
In this time of chaos, it is said that planets happen rapidly as time goes by. About 4.6 billion years ago, as the theory goes, the location of today's solar system was nothing more than a loose collection of gas and dust, or what we call the nebula. And it is said that we almost lost the Earth when a Mars-sized object crashed into it. Up until now, it is still under observation by the scientists to which what really happened.
What caused this is still under investigation. But some scientists believe it was because the gas giants were moving around and perturbing small bodies at the fringe of the solar system. At any rate, in simple terms, the clumping together of protoplanets or planets in formation eventually formed the planets.
Because of the gas giants that is moving around and as what he said, clumping together, that means forming into protoplanets. This is the time that the planets eventually formed into their places.
We can still see leftovers of this process everywhere in the solar system. There is an asteroid belt between Mars and Jupiter that perhaps would have coalesced into a planet had Jupiter's gravity not been so strong. And we also have comets and asteroids that are sometimes considered referred to as building blocks of our solar system.
It is being said that the leftover process was still there in the solar system, for the reason that Mars and Jupiter has an asteroid belt in between, and also the building blocks that our solar system has.
We've described in detail what happened in our solar system, but the important takeaway is that many of these processes are at work in other places. So when we speak about exoplanet system, that is planets beyond our solar system, it is believed that a similar sequence of events took place, but how similar is still being learned.
And lastly, the description in our solar system is still in process. It takes time, or years rather, for us to learn, just like in the other theories.
One major challenge to this theory, of course, is no one was recording the early history of the solar system. That's because the Earth wasn't even formed yet, so it was impossible for any life, let alone intelligent life, to keep track of what was happening to the planets around us.
The protoplanet hypothesis is generally acceptable to most scientists because it explains many of the known facts about the solar system. It is nonetheless far from complete, and the origin of the solar system and Earth is still largely in the realm of speculation. That's why we call it hypothesis, because it is proposed explanation made on the basis of limited evidence as a starting point for further investigation.
There are two major ways astronomers get around this problem. The first is simple observation using powerful telescope such as a large millimeter or submillimeter array. Astronomers can actually observe dusty disks around young planets, so we have numerous examples of the stars with the planets being born around them.
So what is a large millimeter submillimeter array? That large millimeter submillimeter array is the precision multi-tool for mapping the once hidden, detailed activities of the cosmos. ALMA is a premier telescope for studying the first stars and galaxies that emerged from the cosmic dark ages billions of years ago.
The second is using modeling to test their observation hypotheses. Astronomers run computer modeling to see if the ideas work out. Often, they will try to use different conditions during the simulation, such as the perhaps of passing stars triggering challenge in the dust cloud. If the model holds after many runs and under several conditions, it's more likely to be true.
Now let's discuss the modeling. It says that once the model holds on after many runs under several conditions, it's more likely to be true. And in that situation, we can depend on that temporarily.
That said, there is still some complication. We can use modeling yet to exactly predict of how planets in the solar system ended up where they were. Also, in a fine detail, our solar system is a kind of messy place, with a phenomena such as asteroids, big moons.
But again, it's not perfect, of course. We expect some obstacles along the way. We cannot predict what's gonna happen because humans are irrational and emotional, which makes us difficult to anticipate. This is what makes predicting the precise future impact of climate change and many other events difficult. The solar system is a dusty place, and it appears there are still secret hiding among the inner planets. When dust settles in our planetary system, it can form into rings encircling the sun as the material follows the paths of the inner parts. By studying these structures, astronomers may unravel some of the mysteries of the early solar system.
As the protoplanets grew to become planets, parts of them melted due to radioactivity, gravitational influence, and collisions. Where the object had melted, the composition of the planet changed. Heavier elements sank, forming the cores of the planet, and lighter objects rose to the surface. This process is called planetary depression and explain why planets have heavy cores. Astronomers have discovered that even some asteroids have differentiated, so their cores are heavier than their surface.
Protoplanets used to be highly radioactive due to how they were formed. However, over thousands of years, the radioactivity of these objects has greatly decreased because of radioactive decay.
Astronomers are still discovering new protoplanets, and most likely they will discover many more. With better technology, astronomers are now able to find protoplanets in other star systems. It is hard to believe that 1,000 years ago, our planets were just the size of the moon, which were slowly evolving and growing. Astronomers continue to study protoplanets the same way they study planetesimals, to find out more on how the solar system was formed.